All right, in today's reference, we're going to take what we learned from scientific notation and also from exponent rules to learn how to actually multiply and divide with scientific notation. So it's actually something that is very, very simple. To multiply, you just multiply the coefficients and add the exponents. So if you look at the example here, that's kind of just a fancy way of just saying, you copy this down, multiply numbers and add exponents. So the reason that is, well, first of all, if you look at this example, when you multiply, the first thing you do here is 2 times 4. So 2 times 4. And then the second thing you do is add the exponent. So the reason that is because if you think about doing 10 to the 4th here times 10 to the 2nd here, what you're really doing is 10 to the 4th times 10 to the 2nd and multiplying all this together. And we know that this part right here, you just add the exponents. So that's 10 to the 6th. And this part right here, 2 times 4 is just 8. And then it's times 10 to the 6th. So your final answer is this. And of course, this is scientific notation because this is less than 10 but bigger than 1. When you do division, on the other hand, it's very, very similar. You're just going to divide the numbers and subtract the exponents. So divide the coefficients and subtract the exponents of 10. So we'll write that divide numbers and subtract exponents. So in this example, it's pretty easy to see. They even break it out for you. I'll do it on the side too. 4 divided by 2 times, here our exponent is 10 to the 2nd divided by 10 to the 4th. We know that 10 to the 2nd divided by 10 to the 4th has always been 10 to the 2 minus 4. And 4 divided by 2 has always been 2. So really, that simplifies to 2 times 10 to the 2 minus 4 is negative 2. So if we do this here in some examples, for example 1, I zoom in here. Sorry, excuse me. This first example, multiplying, no problem. First thing I'll do is write 2.9 times 1.27 times 10, and we know here we're just going to add the exponents to the 4 plus 3. When I simplify that out, I get 3.683, and then I add my exponents, that's times 10 to the 7th. Again, I did that earlier in my calculator. You could probably do the same as well. Second example, following the same process, I'll write it all out here. 5.11 times 1.6 times my powers of 10. We're going to add these two exponents, negative 4 plus negative 3. So when I do this part of my calculator, it gives me 8.176 times 10 to the negative 4 plus negative 3 is negative 7. So I'll pause the video here and give you a chance to try the 4 examples below, numbers 3, 4, 5, and 6. If you look at the dividing examples, same thing as well. So the first thing we'll do is we'll divide the numbers, 9 divided by 7.5 times 10. Again, we want this in scientific notation, to the 5 minus negative 6. 9 divided by 7.5 is 1.2 times 10, and 5 minus negative 6 is 5 plus 6. This becomes plus a positive, which is 11. And in the second example, you basically divide your numbers again, so it's 7.8 divided by 6.9 times 10 to the, we're dividing using the quotient rule, 3 minus 2. So you're left with, this is actually pretty long in my calculator, but I just rounded it to 1.13 times 10 to the 3 minus 2 is first. I'll pause the video again and have you try the examples on the back. And the last thing that often happens, it's all in capital letters because it's pretty important. Oftentimes you'll need to adjust your answer back into scientific notation because your decimal will not be in the right place because the number will be either greater than 10 or it's going to be less than 1. So I've taught this for many years. In the math lab, we came up with this saying that always helped us. If we have to move the decimal left, you make it larger. And if you have to move it right, you reduce it. So left, make the exponent of 10 larger by how many places you moved. Right, make the exponent of 10 smaller by how many places you move the decimal. So we'll do these 4 quick examples here. So in this first one, the first thing I'll do is I have to move this to make this 45 between 1 and 10. I'm going to move it left 1 spot. So if I go left 1, I'm going to rewrite this as 4.59 times 10. Left is larger, so I'm going to go to the 5 plus 1. So this is 4.59 times 10 to the 6th. In the second example, same thing, except again, we can see this is definitely less than 1, so I have to move it to the right 1. So right 1, so I'm going to write right, reduce. So when I write this one, I'm going to put 6.78 times 10 to the negative 8 minus 1. So that's 6.78 times 10. Negative 8 minus 1 is negative 9. Last 2 examples. I'll pause the video here again, just give you a chance with the partner to see if you can do this. All right, so hopefully you did all right. This will go a little quicker now. So you have to go left 1 to make this 98.6 times 10. So if it's left 1, it's larger. So you have to add 1 here. So this becomes negative 3 plus 1 is negative 2. Same thing with number 4. This is less than 1. We need to move it over to the right 1 this time. So I'll put right, reduce. So here goes. It's going to be 8.9 times 10. If it's right reduced, I'm going to minus 1 here. And 12 minus 1 is 11. Last time, I'll pause the video and you can try the last examples at the bottom. And then we'll try some on whiteboards and practice them together as a class with some classwork.